Okay guys, so we are on domain and range, which is notes 2-2. Okay, we're going to talk about domain and range of continuous graphs. We did do domain and range of discrete graphs yesterday when you were watching the video. So today, moving on to a continuous graph, and just remember that a continuous graph is a graph that is connected with lines or curves. It can still have some dots, but they have to be connected. So a couple of important things. For domain, you want to scan your pencil left to right and identify the X values where you are touching the graph. For range, you want to scan your pencil, and I go bottom to top and identify the Y values where you're touching the graph. Okay, and the reason we go left to right and bottom to top is because that keeps it the small number first and then the big number last. Now, there's this really important note over here that I need you to know. Domain and range of continuous graphs are usually using inequalities, which means a less than or a greater than are an open dot, and then a less than or equal to or a greater than or equal to are a closed dot. Okay, so here's how this works. You're going to just take your pencil, and the first graph is a V. So I'm going to start at the point and I'm going to scan and follow the V to the left. We're not looking at the axes, we're just looking at the V. So when I scan the V to the left, this goes all the way over here, and then there's an arrow. This arrow tells me that that is going to keep going left forever. So I'm going to go back to the V, and I'm now going to scan to the right, and I'm going to see how far it goes to the right. And again, I have an arrow which tells me it goes forever. If it's going to go forever to the left and forever to the right, we have this thing that we call all real numbers. Okay, there's a symbol for it. So if you would rather write the symbol, you write 2 bars like that, and then you connect and make an R. I would take either way for that answer. Now for range, when you're doing range, you scan bottom to top. So I'm going to start at the low spot, that V. This graph doesn't go any lower than the V, so I'm just going to draw a line straight across right there, and that falls at -2. Okay, then I'm going to scan and see how high this graph goes. And when I follow up the long leg of it, there's an arrow, so that tells me that this graph keeps going up forever. So therefore, that there's only one limitation on this graph. So what we're going to do, since range is the y's, we're going to put y, leave a gap, -2. And then we're going to look at the line that I drew, and we're going to decide, is the V above -2 or below -2? So you're just looking at the basic shape. This basic shape is above -2, so above would be a greater than symbol. And since it points and touches right at -2, you put an equal to. Okay, for number 2, when I scan, I'm going to start right in the middle. When I scan to the left, the circle stops right here, and that is at -3. And then when I scan to the right, the circle stops right there, which is at +3. Okay, so since this one has 2 numbers, unlike it goes on forever over here, what you're going to do is you're going to put the small number on the left side of your box, the big number on the right side of your box. You always have to go small to big. You're going to put X in the middle because domain is X, and you use less than symbols always. Now, the reason we use less than symbols is because we are going small to big. The only other question you have to ask yourself is the circle touching on the line I drew, which it is? And then you look over here at 3, is the circle touching on the line I drew? Well, yes, it is. So now I move on, and I'm going to do range, which is bottom to top. So I'm going to scan to the bottom of the circle, and this is the lowest spot of the circle, which falls at -3. And this is the highest spot of the circle, which falls at +3. So I put the small number on the left, the big number on the right. Range is Y. Always, always use less than symbols in between because you have small to big. And then you ask yourself, is the circle touching the line that I drew at -3? It is, so I get a bar. Is the circle touching the line that I drew at +3? It is, so I get a bar. Okay, so now, excuse me, going to number 3. I'm going to start right here in the middle. Remember, we're looking at the slanted line, not the axis. Okay, as I scan to the left, I follow this line and there's an arrow which tells me it's going to just keep going. As I scan to the right, there's another arrow which tells me this just keeps going. So therefore, I know that my domain is all real numbers. Okay, for range, I'm going to start by scanning down. So I'm going to follow the line. I'm not actually going to go down. I'm going to follow the line down. So it goes down as it's going to the right. So as I hit the lowest spot that I can see of the line, there's an arrow. So that tells me this is going to keep going down also as it goes right. And then I'm going to scan over here to the left because that's how it goes up. And as it's going left, it's still going to keep going up. So this one, my range is also all real numbers. Now, this isn't always, but typically if there are arrows on both sides, something is going to be all real numbers. Okay, now for number 4, I'm going to start right here in the middle. This is called a parabola. I'm going to scan the parabola to the left, and I'm going to follow it as far left as I can, and that's the furthest left that it goes. But right there is an arrow, so that tells me it just keeps going left. And then I'm going to go back to the center of it, and I'm going to scan to the right of the parabola, and I'm going to keep scanning. That's as far as it goes, and there's an arrow there, so it tells me it keeps going. So therefore, it's going to go left forever and right forever, so I write all real numbers. Excuse me. Now for the back, for range, I'm going to scan to the bottom. So I'm just going to pick a side because if you look, they're level. So I'm going to pick a side and I'm going to scan down and see how low it goes. Since there's arrows, that tells me it keeps going forever. But if I scan up, this curve is the highest spot of the graph, and that falls at 1, 2, 3, 4, 5. Okay, so since this only has one number, it has one limitation. So we put y, leave a gap, 5. Now I'm going to look at the line that I drew, and I'm going to ask myself, does this line curve above the line I drew, or is the parabola below the line I drew? Well, the parabola is below the line I drew, so this would be a less than, and since the curve touches the line I drew, I put an equal to. Okay, for number 5, I'm going to scan to the left, and it stops right there for the diamond, which is at -1. I'm going to scan to the right, which stops right there, which is at 5. Okay, I'm going to put the small number on the left, the big number on the right. Domain is X, so it goes in the middle. I always use less than symbols. And then I ask myself, is the diamond touching the line I drew? Well, it is. What about over at 5? It is. Okay, so then I move to range and I scan to the bottom of the diamond. This is the lowest spot of the diamond, which is at -3. This is the highest spot of the diamond, which is at +3. So I'm just counting down, counting up. So I start with -3 on the left, +3 on the right. I put y in the middle, always less than symbols. And then I ask, is my diamond touching the line I drew? Well, it is touching at -3, and it's also touching at +3. Okay, for number 6, I'm going to start right here in the middle at this top peak curve, and I'm going to scan to the left and see when this curved line stops. Well, since it has an arrow, that tells me it doesn't stop. It's going to keep going left. So now I'm going to follow along and scan to the right, and it actually dips down and then comes back up. And as I keep going to the right, I see an arrow which tells me it keeps going to the right. Since it's got 2 arrows, that tells me the domain is going to go forever, so all real numbers work. Now for range, I'm again going to start right in the middle, and I'm going to scan down. So as I start moving down to the lowest spot of this graph, I see an arrow, which means this graph is going to continue going down. And as I start scanning up to the highest spot of this graph, there's another arrow, which means it's going to keep going up. So again, your range is all real numbers. One second, guys. Okay, sorry. So continuing on to the back of this page. Now for this problem number 7, this is a wave. So this wave is going to keep continuing. So if I scan to the left and follow the wave to the left, it's going to keep following this pattern since it has an arrow. Okay, and if I scan to the right and keep following it to the right, it's also going to keep following this pattern. So therefore, this is going to go left forever and right forever. So your domain is all real numbers. For your range, if I scan down low, the lowest spot that I see the wave hit is right here for both of these, and that falls at -3. The highest spot that I see the wave hit is up here at this peak, which is at +2. So for range, I put a -3, a +2, range is Y. Always use those less thans, and then I look at my lines. Did the wave touch my line at -3? It did. Did the wave touch my line at +2? It did. Okay, for example 8, I'm going to scan to the left. Well, this is as far left as that graph goes, and that's at -1. And then I'm going to scan to the right, which there is an arrow over here, so that tells me it's going to go forever. I could have scanned this way and it would have also gone forever. So since there's only one number, that means there's one limitation. So we put X and we put a gap with -1. Okay, and then you have to look, since we're talking about X, this is left and right. Is that U shape on the left side of the line I drew or on the right side of the line that I drew? And it's on the right side, so that means greater than. And then is it touching the line I drew, which it is, so equal to. Now for range, I'm going to scan down. And as I scan down, I hit this arrow, which tells me it's going to keep going forever. And as I scan up, I'm going to hit this arrow, which tells me it keeps going forever. So my range is all real numbers. Okay, for domain on number 9, my line is right here. This line does not move left, and it does not move right. This line is stuck, and it's stuck right here at 2. Okay, so we're going to put X, and we're going to put 2. Now, since this is not moving left and not moving right, you cannot use the inequality. It is stuck. The only time you use this symbol is when it is stuck, not moving. So it's stuck, so I put equals to 2. The X will always be 2. Now for range, if I start right here in the middle and I scan down, I can see that this line is going to go down forever, and I can see that this line is going to go up forever. So my range is all real numbers. Now on number 10, if I start right in the middle, this line will go left forever, and it will go right forever. So my domain is all real numbers. Now my range, the line's right here. It never moves up, and it never moves down, so it's stuck right here at -4. Remember, the only time you use it equals is when it's stuck, so we put Y equals -4, and we use Y because this is range. Okay, for number 11, I'm going to start right here at the middle, and I'm going to follow to the left, and it goes all the way to right here, which is at -2. And then I'm going to scan all the way to the right, and it goes over here to this dot, which is at 5. Okay, so for domain, I'm going to put -2, leave a gap 5 because I have 2 numbers. Domain is X. I always use less thans. Now I wrote a note at the beginning of the video about these dots. If it is a closed dot, so if you need to reference really quick, if it is a closed dot, it gets the equals to bar. Okay, well at -2 is touching a closed dot, so I put it equals to bar. If it is an open dot, it does not get the equals to bar, so 5 does not get that bar. Okay, now for range, I'm going to scan to the lowest spot of this graph, and the lowest spot of this graph hits right here, and that's at -2. The highest spot of this graph hits right here, which is at +1. Okay, so I start with -2, bring +1 over here, range is Y, always use less thans, and now look at your dots in your line. -2 in the pink is connecting to a open dot, which means it does not get a bar. 1 isn't touching any dot if you were to extend that line. It's only touching the curve, but the curve is touching it, so it does get the bar. Okay, for number 12, I'm going to scan to the left, and the furthest left spot is this dot right here. And that falls at -4. And then I'm going to scan to the right, and the furthest right dot falls right here, which is at 5. So I put -4, leave a gap 5. Domain is X, so I throw less than symbols in between. Since this is touching a closed dot, I get a bar. Since this is touching a closed dot, I get a bar. Now for range, I scan for my lowest dot, and the lowest dot is down here, which is at -3. The highest dot is up here, which is at 5. Okay, so I write in -3 and 5. Range is Y. Always use less thans. -3's line touches a closed dot, so he gets a bar. 5's line touches a closed dot, so it gets a bar. Okay, for my last two examples, for 13, I'm going to start right here in the middle, and I'm going to scan to the left, and as I scan to the left, I see that it goes forever. Now I'm going to come back to the middle, I'm going to scan to the right, and I see that there's a dot, so I'm not going to go through the dot, but it stops right there, and that's at 2. Okay, so since there's only one number, because it didn't get limited going to the left, I'm going to put X, leave a gap 2, and then I have to look, and if you want to extend this line so you can see, does their line go to the left or go to the right of my line? Their line goes to the left of mine, so left means less, and since it's an open dot, it does not get a bar. Okay, now for range, I'm going to scan down, and as I scan down, it goes the same way as left did, so it's going to go down forever. But as I scan up, it stops right here at this dot again. Well, this dot on the y-axis falls at 0. So I'm going to put Y, leave a gap 0, and then I have to look, does the line that they have go above or below the line that I drew? My line is in pink, so their line is below my pink line. So that means less than, and since it's an open dot, it does not get an equals to bar. On number 14, I'm going to scan to the left, and the furthest left that I see is right here at this dot, which is at -2. And then I'm going to scan to the right, and at the right, the far right, I see an arrow, which means it keeps going. Okay, so this means there's only one limitation, so I put X, leave a gap -2, and then I have to look, is their line, their weird shaped line, going to the left of my line or going to the right of my line? It's going to the right, so that means greater than, and since it's at a closed dot, that's equal to. For range, I'm going to scan down to the lowest spot, and this dot is the lowest spot, and that falls at -4. And then I'm going to scan up to find the highest spot, and the highest spot is up here, which is an arrow, so it's going to keep going up forever. So I only have one limitation again, so I put Y, leave a gap, -4. Okay, I've now got to ask myself, is their line above or below my line? So we're looking at my pink line. Their line went above my line, so that's a greater than. And since it's touching a closed dot, you get an equals to bar. Okay, so now y'all are going to do a practice activity, and if you have any questions, let me know.